Good evening. Today we'll see about how support vector machine works. Actually, it is an algorithm that normal takes less computation power and having some significantly accuracy than other models. So SVM is basically is a support vector machine. So it does both classification and regression tasks. So, but it is widely used. It is used in classification much. So the objective of the SVM is to find a hyperplane in an n-dimensional space where n will be the number of features. I mean, which we take, and it distinctly classifies the data points. To separate two classes of data points, there are many possible hyperplanes that can be chosen. So we in this we will take the margin, so the maximum distance between points of both classes. So maximizing the margin distance provides some reinforcement so that future data points can be classified with more confidence. So next we'll see the implementation. In our dataset, it is a breast cancer dataset. It has some 30 features having radius, texture, perimeter area, smoothness, compactness, concavity. Uh, so concavity gives us the severity of concave portions of the contour, and concave points gives us the number of concave portions of the contour, and symmetry, fractional dimension, and we have 30 features which are linearly separable, and we have some 569 instances in our dataset, and the class distribution will be 212 malignant and 357 benign. So our target class is to predict if it is malignant or benign. So first of all, we have to import the libraries to work with. We have pandas, numpy, and matplotlib um, to plot the data set, and we have from sklearn we have to import the data sets, and we have to load the data set into a variable. Mm, then we have to take the list of feature names, and if we print that we have this many features in our data set. It's like 5 rows, and the last column will be the target column. So totally we have 31 columns. So if we print the target names, as we already discussed, it is malignant and benign. So data set 31 attributes, and 569 data columns, and this is the info, uh, and these are the columns of the data set. So we have to plot it. So for visualizing we have to pair plot the features. So totally we took some features out of it, some 10 or 11, and we have to pair plot everything, and we have this all this all these plots given by SNS pair plot, and then we have target and count. So it is given, one is benign, one is as we already discussed, there are some told you. So there are some 370 or something benign, uh, and the rest are malignant. So we have both are labeled there, and we have to plot it. Here we took mean area and mean smoothness. Then later we have to plot the correlation factor. So the strongest correlation between the mean radius and the mean perimeter, and mean perimeter and mean area also. So we made this. Then we have to go with the x and y variables here. Then we go for printing the x train, y train, and prediction thing. Then we split the data set into 30% into test size and 70% into a training set. Then later we go for kernels. So we have some C parameter, gamma parameter, and degree parameter in our SVM kernels. So so we take so if we see C parameter controls trade-off between classifying training points correctly and having a smoothest decision boundary. So and we have gamma parameter controls like how far the influence of a single training set reaches, and degree parameter of the polynomial kernel function takes poly and ignored by all other kernels. So if we fit the X train and Y train, so we have mentioned the X train and Y train here. So if we fit the X train and Y train and we fit the model, and we have an accuracy of 0.94, like 94% accuracy. And then later if we go for confusion matrix, F1 score and recall score, we have all of it. And if we see the kernel, we can we have poly kernel, degree 2, and gamma auto. So we have model fit X train and Y train. So we have five attributes here. So we have 75% accuracy in here. So then later we have to import SVC, support vector classification. So after that, if we go for So here we have linear kernel, polynomial kernel, and radial kernel. We have given the degree 2 for polynomial kernel, and gamma is auto. And here RBF kernel. So we have tried with three kernels, and we have the test results. And then later we go for hyperparameter tuning. So here we fitting it into five folds, each having 126 candidates, and having totally 630 fits. So then later we go for the best params. So which gives us the which kernel have the best param. So it says that C and gamma 0.25 and the kernel RBF gives us the best thing, and which doesn't overfit or giving the best result. And the best score among this is 0.97. So this is all about hyperparameter tuning in using SVM. Thank you.